Hello friends, and welcome to Webronaq. Here is a question. What if you had to print every number from 1 to 100? You could write 100 separate print statements. That works. But it is painful, it is fragile, and if the requirement changes to 1000, you are in serious trouble. This is the repetition problem, and it shows up everywhere in real programs. Sending an email to every user, processing every item in a cart, scanning every pixel in an image. Writing each step by hand simply does not scale. Loops exist to solve exactly this. They let you write the logic once and tell the computer how many times to repeat it. In this video, we are going to break down exactly how that works, step by step. Let us start by understanding what iteration actually means. Alright, let us define the core idea. Iteration means repeating a block of code, running the same instructions more than once without rewriting them. But a loop does not just repeat forever. It ties that repetition to a condition. Every time the loop runs, it checks the condition. If the condition is true, the code block executes. If it is false, the loop stops. This check-run-stop pattern is the heartbeat of every loop you will ever write. There are three moving parts worth naming now. First, a condition that controls whether execution continues. Second, a body, the block of code that actually runs. Third, a state update that changes something so the condition can eventually become false. Keep those three pieces in mind, because every loop structure we look at is built from exactly them. Now let us see the most common loop shape, the for loop. Now look at this. The for loop packs all three control pieces into one line. Let me walk through each part. We write the keyword for, then open parentheses. First comes the initializer. Here, int I is equal to 0. This runs once before anything else, setting up our counter. Next is the condition. I is less than 5. The loop checks this before every single iteration. If it is true, the body runs. Third is the increment, I increment, which adds 1 to I after each iteration. So the body runs with I equal to 0, then 1, then 2, then 3, then 4. When I reaches 5, the condition is false, and the loop stops. Cout prints each value. The output is 0, 1, 2, 3, 4, 5 values total. The for loop shines when you know the count up front. But what if you do not know how many times you need to repeat? Here is the interesting part. A while loop strips things down to just the condition. You write while, then the condition in parentheses, then the body. That is it. There is no built-in initializer or increment. Those live outside and inside the loop body, and you manage them yourself. Take this example. We set attempts equal to 0 before the loop. The condition checks whether attempts is less than 3. If true, the body runs, and attempts increment adds 1. This keeps going until attempts reaches 3, and then the loop stops. The while loop fits naturally when the number of repetitions depends on something that changes at runtime. Reading lines from a file, waiting for valid user input, or processing data until a certain signal appears. The core logic is identical to the for loop, check, run, update. The structure just makes that flexibility explicit. Next, let us trace exactly what happens inside a single iteration. Let me show you what the computer actually does during a single iteration. We will use our for loop from earlier and trace the moment when I equals 2. Step 1. The loop checks the condition. I is less than 5 is true, so execution continues. Step 2. The body runs. Cout prints the value 2. Step 3. The increment fires. I increment makes I equal to 3. Now the cycle starts again from the top. The condition is checked again. I equals 3 is still less than 5. So the body runs once more and prints 3. This check execute update rhythm repeats on every single iteration without exception. Nothing in the body runs unless the condition passed first. The update you write is the only thing moving the loop forward. Understand this cycle deeply, and most loop bugs become obvious. Speaking of bugs, let us look at the two most common ones. Alright, 2 pitfalls every beginner hits. First, the infinite loop. This happens when the condition never becomes false. Look at the left card. We wrote I minus instead of I increment. I starts at 0 and keeps getting smaller, so I is less than 5 is always true. The program runs forever. Always double check that your update actually moves you toward a false condition. Second, the off by 1 error. Using I is less than 5 runs the loop for I equal to 0, 1, 2, 3, and 4, 5 iterations. Switching to I is less than or equal to 5 adds a 6th. One character changes your output. Write the condition deliberately and trace a couple of values by hand to confirm. So here is the big takeaway. A loop is controlled repetition. Check a condition, run a block, update state, repeat. Master that cycle and you can automate almost anything. Thanks for watching, and we will see you in the next one.